Finding the right medication for a mental health issue is, for so many people, a long and frustrating journey. But what if it didn't have to be? Today, we're diving into a really revolutionary AI that promises to do just that. I mean, just imagine this for a second. What if we could take a snapshot of your brain, feed it into an AI, and have it tell us with near perfect accuracy if a specific medication is going to work for you? It honestly sounds like science fiction, but it might be a whole lot closer than you think. But to really understand why that idea is so incredibly powerful, we have to look at the reality of the situation today. For millions of people, the path to feeling better is this long, painful process of trial and error, trying one thing, then another, just hoping that something, anything, finally clicks. And that brings us to what we're calling the treatment guessing game. To really get a handle on this, we're going to focus specifically on the challenges of treating bipolar disorder. So, bipolar disorder, it's a common, lifelong, and often devastating illness. And for the people living with it, which is up to 6% of the population, by the way, the road to relief can be grueling. The current approach is this frustrating guessing game of just trying one medication after another, hoping something sticks. This can take months, sometimes even years, all while patients are dealing with the illness and the side effects from drugs that might not even be helping them. So the big question is, why? Why is it so ridiculously hard to find the right drug? Well, that's what we're going to dive into next, the long search for a biomarker. You know, for most other conditions, a doctor can run a test, right? A blood test, a culture, something objective to see what's going on. Psychiatry has never really had that. For decades, there just haven't been any clear biological markers to predict who's going to respond to which treatment. It's been a massive hurdle for the entire field. And you might be thinking, well, hold on, what about all those fancy brain scans? And you're right, there's been a ton of research into neuroimaging. But here's the thing. So far, even our most advanced tools haven't given us those clear predictive answers we've been looking for. It's like we've been missing a piece of the puzzle. Until now. And that missing piece just might be a whole new kind of medical detective. So, let's introduce the star of today's show, a really novel AI system called Lithia. So, what makes this AI so special? Well, the first piece of the puzzle is something called fuzzy logic. Okay, think of it like this. A normal light switch is either on or off. It's black or white, yes or no. But a dimmer switch, that can be a little bright, mostly bright, or somewhere in that gray area in between. That's fuzzy logic. It allows the AI to think in shades of gray, which is way more like how the human brain and the real world actually work. The second key ingredient is something called a genetic algorithm. This is where it gets really, really cool. The AI basically mimics natural selection. It creates thousands of different models, thousands of different ways to solve the problem, and then it puts them in this virtual survival of the fittest competition. Only the best performing models survive to reproduce and create the next generation of even better models. It's literally evolution, but for an AI. So you put these two powerful ideas together, and you get Lithia. And here's what makes it a total game changer. A lot of AIs are what's called a black box. You know, data goes in, an answer comes out, but we have no idea how it got there. Lithia is different. It can actually explain its reasoning in simple, plain English if-then statements. It doesn't just give you an answer, it shows you its work. And in medicine, that is a huge deal. Okay, so the theory sounds amazing, right? But how well does it actually work in the real world? Well, it's time for the AI Prediction Challenge. Let's see how Lithia did when it went head-to-head with the competition. Here's how the study worked. They took 20 patients who were experiencing their first manic episode. Now, before any treatment started, they collected a couple of different kinds of brain scans. Then, every single patient got an 8-week trial of lithium. The challenge for the AI was simple, but incredibly difficult. Just by looking at those initial scans, predict who was going to get better. And just to give you a sense of the sheer complexity here, Lithia wasn't just looking at one or two simple numbers. It was analyzing 108 different data points from key brain regions, pulled from 2 different types of scans, fMRI, which measures brain activity, and MRS, which measures brain chemistry. It's like giving the AI a super high-definition, multi-layered map of each person's brain. So, how did it do? Well, this quote from the research paper says it all. When they tested Lithia against 8 other common AI methods, there was one absolutely crucial difference. Only Lithia was able to correctly identify the single patient in the validation group who wouldn't respond to lithium. Only one.
And this chart just drives that point home. It's stunning. Look at the bar on the left, Lithia, with 100% accuracy. 100%. Now look at the bar on the right. That's the average of the 8 other AIs. They were barely better than a coin flip. The difference is just staggering. Lithia wasn't just a little bit better, it was in a completely different league.
Now, results like that are, frankly, mind-blowing. But, and this is a big but, it is from a very small, very early stage study. So we need to step back and look at what this could all mean for the future of mental health care, both the incredible promise and the current reality.
Okay, so on the one hand, the promise here is enormous. We're talking about getting patients the right treatment faster, helping them avoid unnecessary side effects, and using an AI that can even explain its decisions. That is the dream. But on the other hand, we have to stay grounded in reality. This was a tiny pilot study with only 20 people. These findings have to be replicated in much larger, more diverse groups. And these kinds of brain scans, well, they're not exactly part of a routine checkup yet.
But maybe this research points to something even bigger. For decades, we've been searching for that one universal biomarker, that single silver bullet. But what if that was the wrong question all along? What if the future of mental health care isn't about finding one drug that fits everyone, but about using tools like AI to find the unique combination of data that unlocks the perfect treatment for you?